State the number of complex roots of each equation, then find the roots and graph the related function. So there's three things to do. State the number of complex roots, find the roots, graph the related function. To figure out the number of complex roots, you look at the degree of the polynomial. That would be the biggest exponent of any term. In this case, that's a 1. Number of complex roots is a 1. That's supposed to be a 1. Or you could write it like that. To find the roots, you take your polynomial equation and you get x by itself. To do so here, we would add 2 to both sides. So the root for this problem is a 2. To graph the related function, you take the 0 that it's equal to and you replace it with a y. So instead of 0 equals x minus 2, it's y equals x minus 2. So we found the number of complex roots. We found the roots. Now we have to graph the related function. This is a linear function, y-intercept of -2 and a slope of 1. And the x-intercept we just found was 2. That's what a root means. The word root means the same thing as an x-intercept, which means the same thing as a 0 of the function. State the number of complex roots, then find the roots and graph the related function. Well, since the degree of this polynomial was a 2, the number of complex roots is 2. To find the roots, we take our polynomial equation and we solve it. This trinomial is a perfect square trinomial. First term's a perfect square, last term's a perfect square. If you take their square roots of the first and the last, which would be x and 7, and multiply it together, and then double it, you get this middle term, 14x. So here's how it factors. Square root of the first term goes here. Square root of the constant goes here. And then the sign of the middle term goes between them. So it's x minus 7, and that quantity is squared. It's a perfect square trinomial. To get rid of the squared, if you square root both sides, you get x minus 7 equals 0, which gives you x is 7. So the roots for this are 7, and actually 7 again, because you can see here, because this is squared, we have an x minus 7 twice. Going to cross the x-axis one time, it's at 7. Technically, there are 2 roots here, and each of those are 7. You're supposed to graph the related function. The related function is taking the 0 that this is equal to and replacing it with a y. And as we can see from this step here, we could write this as the difference of x and 7 quantity squared. I hope you know what that looks like without using a calculator. It's a parabola whose vertex is moved to the right 7, since this says x minus 7. It opens up because the lead coefficient is positive. To find the y-intercept, if you put 0 in for these x's, you're going to get the y-intercept as 49. Should probably show that here. To find the y-intercept, take the related function, put 0 in for each of the x values. Finished. State the number of complex roots of each equation. Since the leading term has an exponent of 2, the degree of the polynomial is 2, the number of complex roots is 2. Find the roots. To find the roots, you take your polynomial equation and you solve it. This is a trinomial. The lead coefficient is not 1, so the proper mathematical process to use to factor this is to split this middle term into two terms and then factor by grouping. So the first term, 12x squared, stays the same. I'm going to add to that some term, so I have a plus blank x, plus another term, and we're going to subtract 15 from that to get 0. Notice the first terms have stayed the same. The last terms have stayed the same. This middle term is going to get split into two separate terms. One of those being something x and one of those being something x. Don't know what they are. To determine what goes there, you take the lead coefficient, which is a, multiply it by the constant, which is called c. Two numbers that multiply to get a times c. In this case, that's 12 times negative 15, which is negative 180. You need those same two numbers to simultaneously add to what b is. In this case, b is 8. Through a little bit of thinking, you'll find that the numbers that work are 18 and negative 10. Those multiply to get negative 180. Those add to get positive 10. So in one of these blanks, doesn't matter which one, put an 18. On the other one, you put a negative 10, making sure that you have this plus sign between. That is called splitting the middle term. To factor by grouping, you group terms together that have common factors. Typically, just putting the first two terms together plus the last two terms together, typically that is good enough and going to work for nearly every problem, if not every problem. Continuing the factoring by grouping, find the GCF of each group. This first group, greatest common factor is a 6x. So I pull out a 6x to the front. By pulling it out, what I'm really saying is I'm dividing each term by 6x. 12x squared divided by 6x, 2x. 18x divided by 6x, 3. Bring the plus sign down. GCF of the next group looks like it's a negative 5. Leaving me with 2x plus 3. Now examining, I have one term here in the front, I have one term here at the end. Look at each of these terms and find their greatest common factor. Their greatest common factor is 2x plus 3. So I factor that out to the front, and I am now multiplying by that what's left over, which is 6x plus a negative 5, or just 6x minus 5. Fully factored. Now I take each factor, set it equal to 0, solve each of those little equations, and this gives me my roots. Roots means x-intercepts, also means zeros of the function. So all this work here for the roots. Next part of the problem says, graph the related function. Now we know how to graph this related function by taking the derivative of this, finding critical values, and then looking at the critical values to get a critical point, looking at that critical point to see if it's a maximum, minimum, or inflection point. We know how to do that. That's not our focus right now. For this particular section, our focus is on x-intercepts. So take this function and put it in your calculator. Ask your calculator what the minimum is. We know what our roots are. We can find the y-intercept. I want you to show the work for that. To find that, you're going to put 0 in for your x's. Get a y-intercept of 15. We had roots at negative 3/2 and 5/6. If you put this in your calculator and graph it, you're going to find that it has a minimum at negative 1/3, negative 16.3 repeating. Once again, we could find that on our own, just trying to save you a little bit of time. Your time's valuable. but know that if I asked you to find the minimum showing your work, you should be able to do so. There's number 3. This is the related function here. State the number of complex roots of each equation. Well, this lead term has an exponent of 3, which means the degree of the polynomial is 3, which means the number of complex roots is 3. Find the roots. Well, roots are x-intercepts. They're zeros of the function. So we take our function, in this case it's a trinomial, and we try to factor this. First step in factoring, greatest common factor. GCF in this problem is a 3x, leaving us with 2x squared minus x minus 15. Since the lead coefficient is not a 1, we need to take this middle term and to split it into 2 terms and then factor by grouping. When you split this middle term, I would strongly encourage you to always do a plus blank x plus blank x. And then what goes on these blanks is 2 numbers that can multiply to get negative 1, same 2 numbers, add to get negative 1, same 2 numbers multiply to get negative 30. So it's multiplying to get a times c, it's negative 30 in this case. Adding to get b, it's negative 1 in this case. Negative 6 and 5 work, multiplies to get negative 30, adds to get negative 1. So on one of these spots, we're going to put a negative 6, and the other one we're going to put a positive 5. Doesn't matter which is where. Since we have a GCF of this problem, 3x, when I go to this next step, I'm going to put this whole thing in brackets, because within the brackets I'm going to have some parentheses. 2x squared minus 6x, group that together. I'm going to group 5x minus 15 together. The GCF of this first group, 2x. So I factor that out to the front, leaving me with x minus 3. GCF of the second group appears to be a 5, leaving me with x minus 3. Now looking at this term and this term, what they both have in common is an x minus 3. So I can factor that out to the front, and what's left is 2x plus 5, like so. Each time this is equal to 0. To finish this problem, take each factor and set it equal to 0 and solve each of those little equations. So I have 3x equals 0, which gives me x is 0. I have x minus 3 equals 0, which means x is 3. And I have 2x plus 5 equal to 0, which means x is negative 5 halves, or negative 2.5. My roots, negative 5 halves, 0, and 3. Third part of the directions is graph the related function, which we see here. The related function, replace 0 with y, or f of x. To find the y-intercept for this, simply replace all the x values with 0. Find the y-intercept as 0. This graph here is not easily graphed without doing a lot of work, finding the first derivative and the second derivative, setting them equal to 0, get critical values and critical points. We know how to do that, and I'm going to ask you to do that again here in the future. But for this first section, our focus is on x-intercepts and y-intercepts. So please put that into your calculator to find the minimums and maximums. Ask your calculator what those minimums and maximums are. You will find that the graph looks something like this. We have x-intercept of 3, one at 0, and one at negative 5/2. Someplace between we have minimums and maximums. We had a max here, we have a min here. You should be able to ask your calculator what those minimums and maximums are. I did not do that, but you don't have to for your homework, but if I ask you to find them, you should be able to find them, which I'm pretty sure you can. Write the polynomial equation. When it says equation, it means it's set equal to 0, of least degree for each set of roots given. This is real easy in concept. Sometimes the execution is difficult. For each root that you have here, in this case we have 2, you make 2 sets of parentheses being multiplied together. And this is always equal to 0 because it says equation. If it said polynomial function, this wouldn't be a 0, it would be a y, or it would be an f of x. In the first spot of each parentheses, you put an x minus. In the second spot, you put whatever it is you're subtracting. Technically, you should always use parentheses when substituting. Now this needs simplified. X minus a negative 3 is like saying x plus 3. If you multiply this out using the FOIL or box method, you're going to get x squared plus 3x minus 2x minus 6. Middle two terms are like terms. So we end up with the polynomial equation x squared plus 6x minus 6. Write the polynomial equation, that means this is going to be equal to 0, of least degree for each set of roots given. There are 5 roots, so we're going to have 5 sets of parentheses, x minus negative 1, x minus negative 1, x minus 4, x minus 4, x minus 4 equal to 0. Change this a little bit. Subtracting a negative 1 is like adding 1. So we end up with x plus 1 times x plus 1. Multiplying some of these things together, I'm going to multiply these two binomials together first. Since I'm going to multiply these together and it's still being multiplied times things, I need to keep these in parentheses. X times x is x squared. X times 1 is 1x. This 1 times x is 1x. 1x and 1x is 2x. And then 1 times 1 is 1. If I were to multiply x minus 4 times x minus 4, I would get the perfect square trinomial x squared minus 8x plus 16. And I still haven't multiplied this by this last x minus 4, so I bring that down. Continuing here, I'm going to bring down the x squared plus 2x plus 1, and I'm going to multiply these two together. Distributing the x squared times each of these terms, I'm going to get x cubed minus 4x squared. If I distribute the minus 8x times each of these terms, I get minus 8x squared plus 32x. If I distribute the 16 times each of these terms, I get plus 16x minus 64. Equal to 0. Some like terms in here. Here's a pair of like terms, here's a pair of like terms. So this gives us x squared plus 2x plus 1 times x cubed minus 12x squared plus 48x, sorry about my 8, minus 64. Now we need to multiply each term here times each of these terms. Here's how I'm going to do it. I'm going to multiply x squared times each of these terms. Then I'm going to multiply 2x times each of these terms. Then I'm going to multiply 1 times each of these terms. It's going to be quite the hot mess by the time I'm done. So x squared times x cubed is x to the 5th. X squared times minus 12x that would be minus 12x to the 4th. And then x squared times plus 48x would be plus 48x cubed. X squared times a minus 64 is a minus 64x squared. And I'm going to multiply this 2x times each of these terms. When I do this, I'm going to do it in such a way that I'm lining up like terms above each other, so it's easier to combine like terms. 2x times x cubed is 2x to the 4th, positive. I write that underneath if it's like term. 2x times negative 12x squared would be a negative 24x cubed. Write it underneath if it's a like term. 2x times 48x would be 96x squared, positive. And then 2x times a minus 64 is a minus 128x. Now I'm going to multiply 1 times each of these terms. Right there. Product underneath if it's a like term, I get x cubed minus 12x squared plus 48x minus 64, and this whole thing is equal to 0. If I combine these like terms, I'm going to get x to the 5th minus 10x to the 4th plus 25x cubed plus 20x squared minus 80x minus 64 equals 0. So this hot mess right here is the final answer. And that was fun. Write the polynomial equation of least degree for each set of roots given. For each root given, we need a set of parentheses surrounding x minus whatever that root is. Making sure when you substitute, you use parentheses properly. It's a polynomial equation, which means you set it equal to 0. Simplifying this before we start multiplying things out, it's going to give us an x minus 1 times an x plus 1 times an x minus 1 minus I times an x minus 1 plus I. I'm going to multiply these first two binomials together. It's going to end up giving me a difference of 2 squares, x squared minus 1. Middle terms end up canceling. Multiply this hot mess together. I'm going to take the x and multiply it times each of these terms, then the 1 times each of these, that's the minus 1, times each of these terms, then the minus I times each of these terms. Here's what we get. We get x squared minus x plus ix. That's multiplying the x times each of these terms. Multiplying the negative 1 times each of these, we get the following. Negative x plus 1 negative I. Now I'm going to multiply the negative I times each of these terms. Negative I times x is negative ix. Negative I times negative 1 is a plus I. And then negative I times a positive I is a negative I squared. There's some like terms in here that we can combine. we have a negative x and a negative x, which is going to be a negative 2x. We have a plus ix and a minus ix, those cancel. We have a minus I and a plus I, those cancel. We have a plus 1, we have a minus I squared. I squared, what does that mean? Well, here's the one fact that you have to know about i's. You only have to know one. That's the square root of negative 1 is I. Using your algebra skills, if you square both sides of that little equation, on the left you get negative 1, on the right you get I squared, which means that I squared is negative 1. So this right here is a negative 1. We're subtracting a negative 1, which is same as just saying plus 1. Plus 1 on a plus 1 is a plus 2. So we get x squared minus 1 as a binomial, and we get x squared minus 2x plus 2 as a trinomial. Now we need to multiply this binomial and this trinomial together. And here's what happens if you do. You end up with x to the fourth minus 2x cubed plus 2x squared minus x squared plus 2x minus 2. Combine like terms. Here's a couple of like terms right there. We end up with x to the fourth minus 2x cubed plus x squared plus 2x minus 2 equals 0. That's the least degree polynomial equation with the given roots. Solve each equation and graph the related function. Two things to do. Solve the equation. By solving this, we're finding the x-intercepts. Graph the related function. Here's why this problem is in your homework. Here's a problem that with your current skill set, you can't solve. This does not factor. There's 4 terms here. If you try to factor by grouping, you will find that after you find GCFs of each group, the groups aren't the same, so it doesn't factor. To this point, if we haven't known how to factor, we don't know how to do the problem. This chapter, we're going to learn many methods on how to solve equations when you can't factor. We haven't done that yet. So unfortunately for us, if you use your calculator by putting this equation into it and graphing it and asking your calculator for the x-intercepts, you will find it has one x-intercept, one real x-intercept, and it's at 4. If the x-intercept is at 4, what that means is that x minus 4 is a root of this function. To determine what's left of the function if that's a root, in other words, x minus 4 times what becomes this. We take this function and we divide it by x minus 4. X cubed divided by x is x squared. X squared times x is x cubed. X squared times a minus 4 is a minus 4x squared. Add and change the signs. We end up with a minus 2x squared. Bring the next term down. Negative 2x squared divided by x is a negative 2x. Yep, negative 2x. Negative 2x times x is a negative 2x squared. Negative 2x times a minus 4 is a minus 8x. Change the signs and add. Gives us 18x minus 8. I made a mistake here. a minus 2x times a minus 4 is a positive 8. When I change the sign, it makes it a negative. 10x plus a negative 8x is 2x. Sorry about that. And then 2x divided by x is positive 2. 2 times x is 2x. 2 times negative 4 is negative 8. If I change the signs and add, I end up with nothing left, which means this does factor, but I honestly don't know the method that you would use to factor it, which is why I did what I did. At this point, x minus 4 is simplified all the way. X squared minus 2x plus 2 is not, but we need two numbers that multiply to get 2, the same two numbers add to get negative 2. No integers can do that. So we're in a situation yet again where we have this quadratic and we don't know how to solve it. That's why this chapter exists. If you're a little bit confused right now, that's great. That's where you should be, because there's things that we have to do to solve this that you don't know how to do. We're going to learn those things. So the roots for this problem, the only real root that we know of is 4. There's a couple of imaginary ones that we don't know how to find. Graphing the related function, throw this bad boy in your calculator. We could graph this without a calculator, but once again, the focus of this first section is to find roots. And specifically to show you that you can't find all the roots with your current skill set. The y-intercept for this, the x-intercept, we know is 4. The y-intercept, put 0 in for all your x's into the related function. And you find that it is negative 8. So we found the roots and we graph the related function with our calculator. Solve each equation. That means find the x-intercepts. It's equal to 0, and then graph the related function. This factors. It's a trinomial. We need two numbers that multiply to get negative 2 and add to get positive 1. Since the leading term has a coefficient of 1, you do not have to split the middle term. If you chose to, you'd get the same answer. Multiplying to get negative 2. Negative 1 and positive 2 do that. And negative 1 and positive 2 add to get the coefficient of x squared, so that works. X squared minus 1 is the difference of two squares. It factors into an x minus 1 and an x plus 1. X squared plus 2 does not factor. Not using integers anyhow. Set each factor equal to 0. We are finding the roots here. You end up with an x-intercept of 1, negative 1, and plus or minus, oh, pickles, x equals plus or minus the square root of negative 2. Negative 2 square root simplifies to plus or minus I square roots of 2. You can pull an I out, as they say. And your roots are 1, negative 1, and plus or minus I square roots of 2. This, once again, is the roots, the x-intercepts, what we just did. To find the y-intercept, take the related function and put 0 in for all of your x's, and you get a y-intercept of negative 2. To graph it, we could easily do this, finding the derivative, finding critical values and critical points. This first section, our focus is not that. It's just finding x and y intercepts. If you use your calculator, you'll find that it looks something like this. negative 1, 0, 1, 0, you'll find that the y-intercept is the minimum in this graph, coincidentally. Graph the related function of this equation. So in your y1 in your calculator, you type in x cubed minus 4x squared minus 320x. Use the second roots function to find the roots of each equation to the nearest hundredth. It's 2 decimal places. State the range values for the window that shows both the x and y-intercepts. If you do this, you will find the x-intercepts for this problem are 0, 20, and negative 16. A possible window that you could use for this is negative 20, x maximum 25, y minimum negative 400, and y maximum 400. This is not the only window you could use, it's a window that works. Sketch a 4th degree equation. That means the biggest exponent is a 4 for each situation. If the biggest exponent is a 4 and you found the derivative would have the biggest exponent would be a 3. If you solve that equation to find critical points, you would find that it has 3 critical points, possibly. The second derivative would have an exponent, the biggest one would be a 2. If you solve that, that would be 2 critical points. Total, there'd be 3. Pardon me, total there'd be 5. 3 plus 2 is 5. This graph could have 5 critical points. If it did, and it was continuous, it would either have 2 maximums and a minimum, with 2 inflection points, or it would have 2 minimums and a maximum and 2 inflection points. Something like that. So how could we sketch that so that it has no x-intercepts? It never touches the axis. That's easy. Just draw it so that it goes up forever on the left and right, and no part of the graph touches it. 1 x-intercept. Take that same kind of graph, and let's make one of the minimums touch the x-axis. 2 x-intercepts. Take that same kind of graph, and let's make it so 2 of the minimums hit the x-axis. 3 x-intercepts. Let's make it so 1 of the minimums hits the x-axis, and the other one is below the x-axis. It's 3 x-intercepts. 4 x-intercepts, make both your minimums below and your maximum above the x-axis. There's 4 x-intercepts. 5 x-intercepts, it's not possible. The degree of the polynomial was 4. It can have at most 4 roots. Don't be ridiculous. Graph the function on your calculator. Here's what it looks like, basically. Something like that. What is the maximum number of x-intercepts possible for this function? The maximum possible is 5. It's a 5th degree polynomial. How many actual x-intercepts are there? Well, if you look at this graph carefully in your calculator, you'll find that there's actually only 2. It touches the x-axis twice. Why are there fewer x-intercepts than the minimum number? Then it tells you this lovely hint. This is how this problem factors. I have no idea how you would factor it, but that's how it ends up being factored. Notice here that this first part, x plus 2, if you solve that by setting it equal to 0, you get x equals negative 2 as an x-intercept. There's a 2 here, squared. That means it's going to happen twice. X equals negative 2 is used twice. This here, this 3, so this x minus 3 is going to be used 3 times. If you solved x minus 3 equal to 0, you get x equals 3. So x equals 3 is actually used 3 times. That's an algebraic explanation of why you could have 5 x-intercepts possible, but only 2 show up. They're being repeated. The graph doesn't hit it more than once in those places, but theoretically, in an imaginary world where lollipops grew on trees, then actually it does hit it in more than one place at the same time. At liftoff, the Space Shuttle Discovery has a constant acceleration, a, of 16.4 feet per second squared. The initial velocity, v sub 0, due to the rotation of Earth, which is 1341 feet per second, use the function blah 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 to determine the distance from Earth for each time interval t after liftoff. If you take this function and replace the sum of the variables that we know the numbers for, v sub 0 it says is 16.4. That's not true. I messed that up. This here is a, and this here is v sub 0. So we get 1341, that's the initial velocity, times t, plus 1/2 the acceleration, which is 16.4, times t squared. This simplifies to 1341t plus 8.2 t squared. So this is the function that we're going to use to figure out this problem. Some of the variables we could replace with numbers. 30 seconds. Notice that it says that each of these things are in seconds. It says 16.4 feet per second, 1341 feet per second. So when you put these times in, they have to be in seconds. So A, we have d of 30 equals 1341 times 30 plus 8.2 times 30 squared. Showing all of our work, we get 40,230 plus 8.2 times 900. 8.2 times 900, 7,380. When you sum those, you get 47,610 feet. Supposed to figure out how far it is after 1 minute. 1 minute is 60 seconds. So we got d of 60 equals 1341 times 60 plus 8.2 times 60 squared. 1341 times 60 is 80,460. 60 squared, sorry, I said 60 as I was writing an 8, and I had a little bit of a convulsion there. Ignore this. 60 squared is 3,600. 8.2 times 3,600 is 29,520. If you sum those fine numbers, you get 109,980 feet. So after 60 seconds, this space shuttle has traveled 109,980 feet. 2 minutes is 120 seconds. So we're going to substitute d of 120. So 1341 times 120 plus 8.2 times 120 squared. 1341 times 120 is 160,920. 120 squared is 14,400. Eight 8.2 times 14,400 is 118,080. If you sum those, you get 279,000 feet. That's how far the space shuttle has traveled after 2 minutes or 120 seconds. If the time the space shuttle is in flight doubles, does the distance double? Well, there's two reasons why it doesn't. Well, if you look back at your numbers, we went 30 seconds and then 60 seconds. 47,000 doubled is not 109,000. And then from 1 minute to 2 minutes, which the time is doubling, went from 109,000 to 279,000. Didn't double. So the explanation is simple. The relationship is not linear. And the reason it's not linear, if you look at the exponents in the problem, they exist. If you have a variable with an exponent, that's not linear, that's exponential. So the relationship is not linear, that is the explanation.